Elon Musk, currently managing a growing list of companies, including his recent addition of Twitter, remains committed to his enduring passion for space exploration. Despite his busy schedule, Musk, a self-proclaimed nerd, dedicates time to delve into the fascinating world of space travel, particularly expressing immense fascination for the Voyager spacecraft. Recently, he unveiled a startling revelation about a new discovery made by these twin Voyagers in the vastness of deep space. During the launch of the Voyager aircraft by NASA, Elon Musk was just a scrawny 6-year-old, unaware that these spacecraft would later share a surprising connection with his adult endeavors. Remarkably, Musk now conducts commercial rocket launches from Cape Canaveral, the same iconic launch site as the Voyagers. Beyond the age of 50, Musk marvels at the enduring legacy of these spacecraft, surpassing the expectations of their initial 4-year mission. The persistence of the Voyagers continues to provide valuable insights into the mysteries of the distant universe. Unbeknownst to many, the Voyagers owe their existence to a celestial alignment involving the largest 4 planets in our solar system: Jupiter, Saturn, Uranus, and Neptune. This alignment, a rare occurrence not witnessed since the early 19th century during Thomas Jefferson's presidency, played a crucial role in launching the spacecraft. The gravitational pull from each giant planet provided a significant speed boost, akin to an invisible force propelling the probe forward. This ingenious approach, known as gravity assist, dramatically reduced the flight time from Earth to Neptune, from an anticipated 30 years to a mere 12, allowing these resilient spacecraft to venture deeper into the cosmos. The celestial alignment, occurring once every 176 years, presented a unique opportunity that NASA seized by launching spacecraft in the mid-1970s. Recognizing the rarity, NASA constructed 2 identical Voyagers, each comparable in size to an older Volkswagen Beetle. To fulfill the mission tasks, NASA incorporated onboard intelligence, a computer with a mere 69 kilobytes of memory, significantly less than a smartphone or even a key fob for a car door. The spacecraft stored data on 8-track tape recorders, transmitting it back to Earth via a 23-watt transmitter, equivalent to a refrigerator light bulb's power. To enhance signal transmission, both Voyagers carried 12-foot wide dish antennas. Since their 1977 launch, the Voyagers have made numerous discoveries. Voyager 1 now holds the record as the most distant artificial object from Earth, residing billions of miles away in interstellar space. Despite the vast distance, signals take about 2 days to reach Earth. Enduring harsh conditions, extreme cold, pitch-black darkness, and high radiation levels, the spacecraft faces challenges to maintain functionality. Not only do the scientific instruments require power, but the spacecraft must also regulate its temperature in the frigid expanse of space. In the expanse of space where the Voyager spacecraft reside, solar power is impractical as sunlight doesn't reach them. Instead, they depend on radioisotope thermoelectric generators, RTGs, for energy, each carrying 3 RTGs fueled by plutonium-238. The decay of this isotope generates heat, converted into electrical energy, producing 470 watts at 30 volts DC for each Voyager. Despite degradation over time, this method remains one of the limited viable options to power the spacecraft for extended periods. Voyager 1 reached Jupiter in March 1979 after 546 days of travel, while Voyager 2, launched shortly after, followed a distinct trajectory, arriving in July of the same year. Both spacecraft served as stable platforms for Vidicon cameras, employing red, green, and blue filters to capture full-color images. Unlike rapid spinning counterparts, the Voyagers deliberately maintain slow rotational motion, over 15 times slower than a clock's hour hand, minimizing the risk of blurred images. Voyager 1 transmitted remarkable pictures of Jupiter months before reaching the planet, surprising scientists with unprecedented quality and detail. The images of Jupiter's moon, Io, defied expectations with unexpected colors. Before the Voyagers, assumptions about solar system moons mirrored Earth's moon, drab and cratered. The Voyagers shattered these preconceptions, revealing the astonishing diversity of moonscapes around Jupiter and Saturn. The Voyagers boasted significant power during their construction era. Positioned over 1 million miles from Jupiter, the low-energy charged particle, LECP, detector system on board detected unusual signals. Oxygen and sulfur ions, registering a 3-order magnitude increase, initially puzzled scientists. As the Voyager's cameras unveiled Io's volcanic activity, a new revelation emerged. The Moon, slightly larger than Earth's moon, claimed the title of the most volcanically active body in the solar system, surpassing Earth's volcanic activity by tenfold. Io's vibrant colors and unique ions hitting the detector traced back to elements ejected from its colossal volcanoes, like Pele, whose plumes reached 30 times the height of Mount Everest, covering an expanse comparable to France. The Voyagers, armed with cameras capturing over 33,000 images of Jupiter and its moons, unveiled a wealth of previously unknown information. Discoveries included Jupiter's rings, Europa's icy crust estimated to be over 60 miles thick, and the existence of ringed worlds. Post-Saturn, Voyager 1 traversed Saturn's rings, flew past Titan, and turned north out of the planetary plane. Meanwhile, Voyager 2 continued its journey, reaching Uranus and Neptune, identifying 10 new moons around Uranus, and contributing to the growing list of ringed planets. However, these remarkable findings were overshadowed by the tragic explosion of the Space Shuttle Challenger, claiming the lives of all 7 crew members, including Krista McAuliffe, the first civilian teacher selected for space travel. 3 years later, Voyager 2 soared to an altitude of 2,980 miles above Neptune, unveiling remarkable discoveries. It measured the solar system's fastest wind at 1,000 miles per hour and confirmed Neptune's largest moon, Triton, as one of the coldest places with temperatures plummeting to -235 degrees Celsius. Triton featured an ice volcano ejecting nitrogen gas and powdery particles, reaching a height of 5 miles into its hemisphere. Voyager 1, credited with capturing one of Earth's most iconic photos, owes its post-Neptune images to the persistent efforts of renowned astronomer Carl Sagan. After completing its mission objectives at Neptune, NASA intended to deactivate the cameras on both probes, anticipating only the vast void and distant stars beyond the planet. Despite the mission extension in the hopes of reaching interstellar space, no further photos were planned. Sagan, however, appealed to NASA for one last batch of photos. Influenced by his plea, Voyager 1 turned its camera back towards Earth on Valentine's Day of 1990, capturing 60 final shots. The most poignant among them is known as the pale blue dot, portraying Earth from a distance of 3.8 billion miles, the farthest portrait ever taken. Earth is barely discernible, appearing as a mere pixel veiled by sunlight reflecting off the camera's optics. The Voyagers maintain contact with the control center, but each day, they recede by 3 to 4 light seconds. Utilizing NASA's Deep Space Network, consisting of 3 tracking complexes strategically positioned around Earth, scientists stay connected to the spacecraft. Having crossed the heliopause on their trajectory out of the solar system, Voyager 1 achieved this milestone in August 2012, with its twin following suit more than 6 years later. Despite their age, these spacecraft still have the capacity to surprise. Recently, Voyager 1 transmitted perplexing data, specifically from its Attitude Articulation and Control System, AACS, responsible for orientation, antenna alignment, and attitude maneuvers. NASA's scientists express uncertainty about the validity of the data, considering the possibility of random generation. While Voyager 1 generally operates well, the team scrutinizes signals closely, aiming to discern whether the irregular data originates from the AACS or another system involved in telemetry data production and transmission. A potential solution involves addressing the issue through a software update. These challenges aren't the first for the Voyagers. In 2017, Voyager 1's primary thrusters showed signs of aging. Engineers swiftly switched to a set of thrusters that had operated during the mission's planetary encounters 37 years earlier, and remarkably, the second set performed flawlessly, an illustration of the spacecraft's remarkable longevity and clever design. Voyager 2, meanwhile, has only 5 operational instruments, with some functions deactivated to conserve power. The cosmic ray detector's heater, determining heliopause crossing, was turned off. Voyager 1 faces more limitations, with only 4 working instruments. The last to be deactivated will likely be the magnetometer and the plasma science instrument, shielded within the spacecraft's body to retain some warmth from computer-generated heat. Even with all instruments turned off, the Voyagers will persist in their interstellar journey, potentially reaching our nearest star, Proxima Centauri, approximately 16,700 years in the future. Share your thoughts on the Voyagers in the comments section below.